Good morning, everybody. This is G. Narsimhulu, Associate Professor, St. Peter's Engineering College. Today we are going to discuss about parameters, H-parameter model. This H-parameter model using to analyze the BJT and MOSFET for the small signal analysis. Let me consider two-port network. Two-port network which is having two ports. One is input port and another one is output port. Let us consider this I1 is the input current and V1 is the input voltage, I2 is the output current and V2 is the output voltage. Then we can write the equations like impedance parameters and admittance parameter and H parameters. In impedance parameter, I1, I2 acting like a independent variables, but V1, V2 are acting like a dependent variables. Why? Because V1 is function of I1, I2. V2 is function of I1, I2. You know that when mathematically you can write the equation V1, V2 in function of I1, I2. Here V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. Means Z11 is nothing but V1 divided by I1 when output circuit is open. Z12 V1 divided by I2 when input circuit is open. Z21 V2 divided by I1 when input circuit is short circuited. When Z22 V2 divided by I2 when input circuit is open. There you should understand V1 depends on I1, I2. V2 depends on I1, I2. Mathematically, you can write in the matrix forms V1, V2 is equal to Z11, Z12, Z21, Z22 matrix into I1, I2, where Z are the impedance for the AC, or you can be consider Z is the resistance for the DC, which you can be determined by using formula Z11 is equal to V1 divided by I1 when I2 is 0. It is also known as input impedance when the output circuit is open. You can also name like this open circuit input impedance. Z12 is equal to V1 divided by V2 and I1 is equal to 0 is a reverse transfer impedance. Reverse transfer impedance when the input is open circuit reverse transfer impedance. Z21 is equal to V2 divided by I1 where I2 is equal to 0 is a forward transfer impedance when the output is open circuited or open circuit forward transfer impedance. Z22 nothing but V2 divided by I2 when I1 is equal to 0. It is the output impedance when the input is open or open circuit output impedance. The Z parameters also known as open circuit parameters, since in these parameters either input output is open circuit. To determine some parameter Z11, Z12, Z21, Z22, all these parameters, one of the circuit is opening, so that you can be say these parameters either input or output is open circuited. The equivalent circuit of the network using Z parameters is given like this. You can be understand V1 is equal to Z1 into I1 plus Z12 into I2. Z12 is nothing but it is the impedance of the input circuit, okay, due to the current output current passing through the input circuit. Z21 is the impedance of the output circuit due to the current I1 current is passing through the output circuit. And Z11 is nothing but impedance of the input circuit, the current which is passing through the input circuit. I1 current is passing through the input circuit. Z22 is the impedance of the output circuit, where I2 current is passing through the output circuit. This is the understanding of the Z parameters. Admittance parameters. This is the reverse of the impedance. Here V1, V2 are the independent variables. I1, I2 are the dependent variables. You can say I1 is equal function of V1, V2. I2 is equal function of V1, V2. You can write mathematically. I1 is equal to V11, V1 plus V12, V2. I2 is equal to Y21, V1 plus Y22, V2. How you can write all these equations? Very simple. I is equal V by R, or I is equal V by Z. You can be right for the AC. 1 by Z is nothing but admittance. You can write this one, admittance is with Y. 1 by Z is equal to Y. 1 by Y is equal to Z. That is understanding. Here Y in the sense it is admittance. In terms of impedance, you can be right Y11 is equal to Y11 is equal to 1 by Z11. Y12 is equal to 1 by Z12. Y21 is equal to 1 by Z21. Y22 is equal to 1 by Z22. You can write this one in the mathematics form. I1, I2. Matrix is equal to Y11, Y12, Y21, Y22 into V1, V2, where Y is the admittance. You can also call it conductance for the DC circuit, which may be defined like Y11, where output is short circuited. That is Y11 is equal to I1 divided by V1. That is the input admittance when the output is short circuited. And Y12 is nothing but I1 divided by V2, where input circuit is short circuited. This also called as a reverse transfer admittance. And Y21, I2 divided by V1, where output circuit is short circuited. This is forward transfer admittance. Y22, it is I2 divided by V2. It is a output admittance when the input circuit is shorted. These Y parameters also called as short circuit parameters. Z parameters also called as open circuit parameters. Here you can be right. You can draw the admittance parameter equivalent circuit like this. Here you should understand Y11 is the admittance of this input circuit. When you have the I1 current is passing through the input circuit only. Y12 It is a reverse transfer admittance. It is admittance in input circuit due to I2 current passing into the input circuit. This is forward transfer admittance. This is the admittance of the output circuit when input current is passing in the output circuit. Y22 is nothing but admittance of the output circuit when output current is passing through the output circuit. Previously, this is in series with some other parameter like Z11 is in series with the Z21, sorry, Z12. Y22 is in series with the Z22 is in series with the Z21, but which are parallel now. Why? Because you should understand these things. I1 is equal Y1 plus V1. This is nothing but current. Okay, current equations. Just you have to understand. This is some current. This is some current. Okay, this is one current. This is one current. You should understand. This is current one. Current. This is a current uh, equivalent diagram. Okay, like this. Hybrid parameters. It is mixing of admittance as well as the impedance. Hybrid parameters may be defined by using I1, V2 as the independent variables and V1, I2 are the dependent variables. V1 is equal to H11 I1 plus H12 V2. I2 is equal to H21 I1 plus H22 V2. Mathematically or matrix form you can be write V1 I2 is equal to H11 H12 H21 H22 into I1 I2 I1 V2. What is the H11? What is the H12? What is the H21? What's H22? We have to know. H11 is equal to V1 divided by I1, where V2 is short circuited. It means that output is short circuited. This you can be say input impedance when output is shorted. And H12 V1 divided by V2 when I1 is 0. It is nothing but reverse transfer voltage ratio when input is open circuited. H21 I2 divided by I1 forward transfer current ratio. Okay, when output is short circuited. This H21 H21 where is the H21 this one H21 is equal I2 divided by I1 when V2 is 0 is a forward transfer current ratio when the input is open circuit or open circuit forward transfer current, not like this. This is a wrong statement. Output is short circuited. Here also you can be see H1 to V1 divided by V2 when I1 is equal to 0. Input is open circuited. Input is open circuited. This one is output is short circuited. This one wrong statement. Next, H22 is equal to I2 divided by V2 when I1 is equal to 0. Where is the H22? This one. This I2 divided by V2 when I1 is equal to 0. I1 is equal to 0 happens when input circuit is open circuited. That it can be called output admittance. Equivalent circuit you can be draw like this. I1, H11, okay, H12, V2, H21, V1, H22 and I2. This one is voltage source. This one is current source. And let us draw this low frequency H-parameter model of transistor. We consider common emitter configuration since it most commonly used amplifier. Now you should understand in common emitter configuration, emitter is connected to ground. base is acting like input terminal, collector is acting like output terminal. Now you have to be draw this one by using H parameters, how it is. Here you could understand, okay, like a two-port model network. Input voltage like a V1. V1 is nothing but VBE, and you could understand I1 is nothing but IB, and you should understand um, V2 is nothing but VCE. You should understand I2 is nothing but IC. By using these formulas, you can be rewrite the equation like VBE, input voltage, input current, is a function of output voltage and output current. Sorry, input voltage and output current is function of input current and output voltage. Now you can write VB is equal H11 IB plus H12 VCE, where IC is equal to H21 IB plus H22 VCE. Now you have to determine what is the H11, H12, H21, H22. H11, it is nothing but VB divided by IB, where VC is 0. When VC is 0 means it is input resistance with output is shorted. It is represented as HIE. It is the input resistance for the emitter configuration. This suffix you can be understand that when it is the CE configuration. Next H12, it is equal to VBE divided by VCE when IB is equals 0. This is a reverse transfer voltage ratio when the input is open. It is represented by HRE, reverse transfer voltage ratio. Next H21 is IC divided by IB where VC is equal to 0. It is a forward transfer current ratio when output is shorted. Output is shorted. Then H22 is equal IC divided by VC. IB when IB is equal to 0 is the output conductance where the input is open. It is represented as HY. In all these parameters, the subscript E is used for the common emitter configuration. For common base and common collector configuration, the subscript E will be replaced with B and C respectively. Thus, common emitter H parameters equation in the form of traditional symbols. You can be right. VBE is equal HIE IB plus HRE VCE. IC is equal HFE IB plus HOE VCE. You can also write the H parameters in another way. You can also write this H parameter for the CB, H parameter for the CC also. You see this one for the CB configuration, base is connected to the ground. What is the output current? Collector current. What is the input current? Emitter current. What is the input voltage? Emitter to base voltage. What is the output voltage? Collector to base voltage. So you should understand input voltage and output current, which are depends upon the input current and output voltage. So you can write this equation. VEB is equal to HIB IE plus HRB VCB. IC is equal to HFB IE plus HOB VCB. You can also redraw the circuit like this. Okay. Similarly, H parameter equations in CC configuration. We should understand for the CC configuration, collector is grounded. Output current is emitter current. What is the input current? Base current. So you could understand VBC, it is the input voltage, output current are dependent on input current and output voltage. So you can see VBC is equal to HIC IB plus HREC and IE is equal to HFC IB plus HOC VEC, and the circuit diagram corresponding to this. You can also convert H parameters in three configurations. Step 1. Write the set of H parameter equations in the given configuration. Draw the circuit model in the given configuration. Write the set of H-parameter equations in the required configuration. Redraw the circuit model in the required configuration. Using the circuit model obtained in the step 4, write the some possible equations. By doing some manipulations in these equations, a set of two equations in the format of required configurations obtained. Comparing the equation in step 5 with the H-parameter equations in the required configurations in step 3. The required H-parameters are obtained in terms of the parameters of given configuration. Today class is finished. Again we'll go with the extension of this topic tomorrow. Thank you one and all.